two objects slide over a frictionless horizontal surface. When you read frictionless, you're thinking no non-conservative forces. So total energy of the system will be conserved. The first object of mass 5 kg is propelled with a speed of 4.5 meters per second towards the second object of mass 2.5 kg, which is initially at rest. So let this be my second object, which is initially at rest. This is the first one. Let's make its velocity along the positive x direction, right? And this object is at rest, so let this be my origin. That simplifies things a bit mathematically for me. Continuing reading. After the collision, both objects have velocities that are directed 30 degrees on either side of the original line of motion of the first object. So 30 degrees north of east, that's the positive x direction, and 30 degrees south of east. Okay, let this be M1 goes this way and M2 goes this way. So we have V2 final here, we have V1 final here. What are the speeds of the two objects? So we need to find this V1 final, V2 final. We have two unknowns, we need at least two equations. Part B, is the collision elastic or inelastic? The difference between inelastic and elastic is that of whether kinetic energy is conserved or not. So once you have those final velocities, and you know all the velocities and all the masses, then you need to compare your total kinetic energy initially with the total kinetic energy after collision. And if they are the same, then we had an elastic collision. Otherwise, inelastic. Okay? But first, for the first part, what are the final speeds of the objects? So what can we do? How can we find a relationship between the known and unknown quantities? That's right. You have a collision, you're going to do conservation of linear momentum, and you're going to split it into conservation of linear momentum along x and conservation of linear momentum along y, right? So if we look at that, what's my linear momentum initially along x? This mass has no linear momentum because it's not moving, so its velocity v2 initial equals 0. What is the linear momentum from here? We have m1 v1 initial, right, along x. All of it is along x, so whatever its initial velocity was equals the x components of these two momenta, yeah, which is m2 v2 final, and I need to take its x component, which is going to be cosine of this angle theta, right? So I'm going to use the system where I'm measuring from the positive x direction counterclockwise. So this angle we already know is given to us as 30 degrees. And this angle is also 30 degrees, which means this entire angle here for this one from positive x direction counterclockwise is going to be 360 minus 30. That's 330 degrees. Huh? So to the x component of this one, I need to add the x component of this one. So that is going to be my second term, m1 v1 final, and its x component is going to be cosine of 330 degrees. Yeah? And now I don't need to be careful about whether it was positive or negative, because this cosine of 330 degrees will automatically come out to be the positive sign or negative sign, the correct sign that I needed to take. Similarly, I need to work it out for the y direction, right? So this entire thing is my equation in the x direction. In the y direction, I have no initial component of the velocity. All my velocity was along x. So my initial y equation, initial momentum was 0. That means the momenta of this must be equal and opposite the momenta of this, so that I have no final momentum. That also needs to come out to be 0. So what do I get? I get, let's do the up one first, m2 sine of 30 degrees times v2 final. Should have written that earlier, but I missed out writing it. v2 final, right? So this is, all of this is the y component of v2f plus the y component of this one, and I'm going to follow the same system, so I don't need to be careful of the sign. This one I'll write first v1f that's the magnitude, times the cosine, sorry, so I need to erase this. Let's type it in again. We have cosine of 330 degrees. And again, the positive or negative sign will get taken care of by the value of that cosine of 330 degrees. Okay, so here you have two equations, one in the x direction, one in the y direction. You're going to substitute values in them and solve for V2F and V1F. Yeah, these are your only two unknowns. And that should give you your results, which we'll look at on the next slide. So here's the diagram again, 30 degrees. And in this case, unfortunately, when I scanned it, some of it has got cut off, but this is cosine of 330 degrees, okay? And you're going to get your two equations. You're going to solve for V1 and V2F, and this continues on the next page. When you solve for it, you're going to get V2F as 5.2 meters per second, V1F is 2.6 meters per second. And for part B, remember we said we're going to calculate the total kinetic energy initially and total kinetic energy finally, and they both come out to be the same number, 50.63 joules. So we can say that, confidently say that this is an elastic collision.